Today we're going to take a look at some applications of right triangle trig. So for our first example, we have a 6-foot man who is standing 15 feet away from a tree, and he sights the top of the tree with an angle of elevation of 38 degrees. And we're going to find the height of the tree to the nearest tenth of a foot. So I'm going to start off by drawing a picture. So here's the man. We know that he's 6 feet tall, and he is standing 15 feet away from a tree. So here's our tree, and we know this distance here is 15 feet. And when it says that he sights the top of the tree with an angle of elevation of 38 degrees, what that means is if this man were to look straight across, so parallel with the ground, and then if he were to look up to the top of the tree, this angle that is formed, that's our angle of elevation, which is 38 degrees. And our job here is to find the height of the tree. So we want to find this height here. And in order to do that, well, we know this kind of bottom part is 6 feet. That's just the height of the man. And so we need to know this part here, which if you take a look at this picture, we actually have a right triangle. Notice right in here we have a right angle. And this right triangle, using a sine, cosine, or tangent function, we're going to be able to find the leg of this right triangle. So let me label this leg here, because that's what we need to find in order to find our height. So let's call this, how about y? So, and if we want to find the total height of the tree, well, we're going to take this leg of our right triangle, which is y, plus this bottom part, this bottom 6 feet. And when we do that, that'll give us the total height of the tree. Okay, so let's find y. And remember, our trig functions that we have to choose from are sine, cosine, and tangent. And if we look at our right triangle, if I were to label some of these sides here, so y, notice this is the opposite side from the angle that we know, which is 38 degrees. And then this other leg of our right triangle, which we know has a length of 15, this is the adjacent side. So for our right triangle, we know the adjacent side, and we're trying to find the opposite side. So which of our trig functions uses opposite and adjacent? And if we remember, that's actually the tangent function. Tangent is opposite over adjacent. Right? Sine and cosine, let's see, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. And notice we don't know what our hypotenuse is, nor do we even care what it is for this problem. So tangent is definitely the function that we want to use. Okay, so if we set up our equation, we can say that tangent of 38 degrees, that's our angle, and that's equal to opposite over adjacent. And our opposite side, that's what we are calling y, and our adjacent side, that's 15. And now we need to solve for y, which I can do by multiplying both sides by 15. And we end up with y is equal to, notice these 15s reduce. So we get y is equal to 15 times tangent of 38 degrees. And at this point we can plug into a calculator. And if you do that, you should get approximately 11.7. I'm just going to round to one decimal place because after all, we're asked to find the height to the nearest tenth of a foot. So that'd be one decimal place. Cool, and our units here are feet. And now to just finish the problem, the total height of the tree is going to be equal to this 11.7 feet plus that 6 feet, which accounts for the height of the man. So that gives us a total of 17.7 feet as the total height of our tree. All right, let's look at another example. So in example 2, what we have is a man in a hot air balloon, and this hot air balloon is 400 feet above the ground. And he looks down at the ground and he sights his friend with an angle of depression of 70 degrees. Okay, so let's start by drawing a picture. So here's my hot air balloon. Here's the man inside the hot air balloon. And let's see, we know that the hot air balloon is 400 feet above the ground. So this distance here is 400 feet. And here's his friend down on the ground. And he looks down at his friend, and the angle of depression is 70 degrees. So what that means is if this man in the hot air balloon were to look straight across, and then if you were to look down, this angle that is formed is the angle of depression, 70 degrees. Now, if we take a look at our picture, first of all, do we see a right triangle? And yes, we do. Here's our right angle. Okay. And we know this leg of our right triangle. And notice we know this angle, 70 degrees, but what we would like is actually an interior angle in our right triangle. But because this guy is 70 degrees and this entire angle should be 90, in order to find this interior angle in the triangle, all we need to do is 90 degrees minus 70 degrees, and that'll give us our interior angle of 20 degrees. All right, so we have one of the legs of our triangle, we have an angle, we should be able to find some other information about this triangle, but let's see what the question is asking. So part A says, find the distance between the man and his friend. Okay, I'm gonna use a different color here. So the distance between the man and his friend, well, here's the man, here's his friend. To find that distance, well, that's basically finding the hypotenuse of our right triangle. So let's go ahead and label this, and you can call it whatever variable you want. I'm going to call it capital H for hypotenuse. Okay, so for part A, what we need to do is find the hypotenuse. Let's take a look at part B and identify what we need to find for part B. So let's see, we need to find the distance between the friend and the spot on the ground that's directly beneath the hot air balloon. Okay, so here's the friend. Here's the spot on the ground directly beneath the hot air balloon, and what we need to do is find this distance, so the other leg of our right triangle. So let's label it something. How about I'm going to call it X. So in order to answer part B, we need to find X. Okay, so let's set up our trig equations, which are going to help us find these lengths. So let's start with part A. Okay. And let's see. For part A, we need to find the hypotenuse. And what we know is the adjacent side to our angle. So which trig function uses the hypotenuse in the adjacent side? And I think that's the cosine function, right? Cosine is adjacent over hypotenuse. So that's what we're going to use for part A. So if we set up our equation, we'll have cosine of our angle, and our interior angle again is 20 degrees. And that's going to be equal to the adjacent side, which is 400, divided by the hypotenuse h. And now to solve for h, we're going to multiply. We're going to clear that denominator. I'm just going to multiply both sides by h. So when we do that, what we have is h times cosine of 20 degrees is equal to 400. And then I can finish by dividing both sides by cosine of 20 degrees. So in the end, we have h is equal to 400 over cosine of 20 degrees. And if you plug this into a calculator, you should get approximately 425.7. And of course, our units here are feet. And so this would be our answer to part A. Let's take a look at part B. Okay. So now in part B, we're trying to find this bottom side of our right triangle, X, which notice this is the opposite side from our angle, right? Here's our angle, X is opposite from it. And the other side of our triangle that we know, actually we know the hypotenuse and our adjacent side at this point. However, our hypotenuse is just an approximation. So I want to use the adjacent side when we go to solve part B. Okay, so which trig function utilizes the adjacent side and the opposite side? Well, that's the tangent function. Oh, what happened there? Tangent. So tangent is opposite over adjacent. And so that's the function we'll use. So tangent of our angle, 20 degrees, is equal to the opposite side, which is x, divided by the adjacent side, which is 400. And now to solve for x, I'll just multiply both sides by 400. Those guys cancel. And what we get is x is equal to 400 times tangent of 20 degrees. And we can plug that into a calculator. And if you do that, you should get approximately 145.6 feet. And there we go.